all, welcome back. So today we will solve questions from continuity and differentiability which came in different shifts of April 2025 attempt. In continuity and differentiability we have total 3 questions out of which 3 are easily doable which we are going to solve. And this difficulty level is basis my perception which may be different for others. So let's jump on to our first question. Before we start our first question, here we have analysis page for each and every questions with their difficulty level. Hope this will be helpful for you. So here is our first question. Our question says, let f of x is equal to this piecewise function be continuous at x is equal to 0, then e raised to power a into bc is equal to. Now for this function to be continuous, our limit x tends to 0 of 1 plus a raised to power x, 1 plus a into x whole raised to power 1 upon x should be equal to the value for the function at x is equal to 0, 1 plus b. Now clearly this is 1 raised to power infinity form, so we can write it as e raised to power limit x tends to 0, limit x tends to 0, 1 plus ax minus 1, so ax into 1 upon x. Here x and x will get cancelled. This is equal to 1 plus b. From here we will get e raised to power a is equal to 1 plus b. Now we will do the same for x greater than 0, this expression. Limit x tends to 0 of x plus 4 raised to power 1 upon 2 minus 2 divided by x plus c 1 upon 3 minus 2. Now this is equal to 1 plus b. Now for this limit to exist, for limit to exist, our c should be equal to 8. Our c should be equal to 8 because when we will take our c is equal to 8, we will get a form of 0 upon 0 which we can solve. Now here we are going to use using LH rule. Using LH rule, this will be limit x tends to 0, 1 upon 2 x plus 4 raised to power minus 1 upon 2 divided by 1 upon 3 x plus c, we can write x plus 8 raised to power minus 2 upon 3, and this is equal to 1 plus b. Now when limit x tends to 0, this expression will be 3 upon 2, numerator will be 4 raised to power minus 1 upon 2, so 1 upon 2 into 8 raised to power minus 2 upon 3 will be 1 upon 4, 1 upon 1 upon 4 will be 4. Now 2 and 4 will get cancelled. This is equal to 1 plus b. From here b is equal to 2. If our b is equal to 2, from here e raised to power a is equal to 3. So our e raised to power a into b into c is equal to 3 into 2 into 8, which is equal to 48. 6 into 8, 48. So our answer will be option C. And here is, please wait a minute. Yes. And here is our solution. And we can see that our answer is correct. Here is our next question. This time our question says that m and n be the number of points at which the function f of x is equal to this max of these terms. X belongs to R, is not differentiable and not continuous respectively, then m plus n is equal to. So here our f of x is equal to, it will be x if our x is less than minus 1. It will be x raised to power 21 if x is greater than equal to minus 1 and less than 0. It will again be x when x is between 0 and 1, and it will be x raised to power 21 if x is greater than 1. So from here we can see f of x is continuous at minus 1, 0 and 1. So we can say f of x is continuous and x belongs to R for all real numbers, and not continuous is n. So our n is equal to 0. Now let's find f dash x. F dash x is equal to, let's take derivative of all the pieces. This will be 121x 21 and 21x 20. Here x is less than minus 1, minus 1 greater than equal to x less than 0, 0 greater than equal to x less than 1, x greater than equal to 1. Now here our f of x is not differentiable at points minus 1, 0 and 1 at x is equal to minus 1, 0, 1. So from here our m is equal to 3. So from here we can say that m plus n is equal to 3. So our answer will be is equal to 3. And here is the solution. We can see that our answer is correct. Here is our next question. This time our question says the number of points of discontinuity of the function f of x, where x belongs to 0 to 4, where this denotes greatest integer function is. So first we will check doubtful points. Check where x square upon 2 and root x, where these two terms are integers inside int, are integer. So for these two to be integer, x will be not simultaneously, so then x will be 0, 1. For 0 and 1 both are in, for 0 Both are integers. For 1, this is not integer, but this is integer. And root 2, root 4 will be 2. Root 6, root 8, root 10, root 12, root 14, and for root 16 this will be 4. For 4 this will be integer. Now because our interval is between 0 to 4, we can say it is continuous. F is continuous at x is equal to 0 plus and 4 minus. So the remaining points are 1, 2, 3, 4, 5, 6, 7, 8. From here our answer is equal to 8. So from here our answer will be 8. And we can see that our answer matches correctly. So hope you found this video helpful. Thank you for watching.